Hello guys, welcome back. So let's finish this lecture by implementing the quick sort in this video. So if you guys don't know, like this is a continuation of the previous video where we have implemented the helper pivot function. Here is the code of that, and if you want to get the snippet, you go in the description of the previous video and get your code. Okay, and let's start continuing on like quick sort implementation, right? And let's finish it. Okay, so what we have done so far is like we have created a helper function. What it will do, it will pick a pivot, it will move all the elements which are smaller than it on the left side and all the elements which are larger than it on the right side, right? This is what it have done so far, right? So now we have to create a function which is going to basically split the arrays into the halves, right? So let's say you have picked a pivot point. So I want to pick the left side of it uh, in one array, and then I have to split right side of it in one array, right? And then I have to again call the helper pivot function in those arrays over and over recursively. Okay, so now how we can do that? Okay, so that is the simplest logic, but it may take some time for you to understand. So that's why I will split this video in two parts. Here I'll do just implementation. Okay, I'll do the code walkthrough, and then in next lecture we will see how it is working in terms of browser, right? In terms of call stack, right? So let's start implementing it, and before that I think I have to remove few things from here. So this console log I think I don't need at all. Okay, I was removing this swappy index also. I don't need this console log now in this code because you guys are already aware how it is working. This array also I don't need. Okay, and here end index is not used anywhere, so I'll remove this as well. Okay, since it is not used anywhere. Okay, now this console log also, let's keep it commented for now. Okay, now let's quickly discuss what we are going to implement. Okay, so let's say we have an array, right? 57219. Okay, so here we took a pivot point as 5. Okay, so now what we are going to do, we are going to split this thing into the half, right? So let's say we have picked this pivot point and then we have swapped this element, let's say here. Okay, so this is the pivot is 5, and then we have swapped the elements, like we called our helper pivot function, and what it does, it moved all the smaller elements in the right side, left side, and then larger elements in the right side. Okay, now the same process we are going to repeat for this array and this array. Okay, so it will be basically like this. So here it will be 4 to 1. Okay, and second array is going to be this one. Okay, now in this array also we will do the same thing. We will pick a pivot point, let's say 4. Okay, so we have took 4. So what we will do, we will move all the elements on the right side. Okay, so it will be something like this, 2 1 4, right? And then here also we will do the same thing. Here we will take pivot as 9, and then we will move all the elements smaller than 9 on the right side, right? So here the array is going to be something like 8 7 6 9, right? And then we will keep on repeating the process over and over again until we reach the last two elements, right? So let's say we have took the pivot point, and then again we have these two areas, right? So now we have these two, we will pick one pivot point, and then we'll pick 2 as a pivot point. So here let's say 2 as a pivot point, and then what we'll do, we'll move all the elements which are smaller than 2 on the right side. So it will become 1 comma 2, right? So this is the point where we have to stop, because after this, if we pass the array again into the helper function or the function which we are going to implement, so what will happen if you pass the array now? So we will have just one element, right? So the pivot will be this one. Okay, so starting index or ending index, we can say the left and right side will be the same, right? So we just have one element. So our implementation is start failing in this point. So we have to stop it at this point where we get two elements until we get the left index is smaller than the right index. Okay, if the left index and right index are same, that means we have just one element, because that is the only case where we are going to get the left and right index as same, right? So if we get the elements in the array, like the length of the array is 2, or we can say smaller than 3, right, or smaller than equals to 2, then we have to stop calling the functions and then we have to return the array. That means we have reached the point where we found the elements which we can swap and then we can return. Okay, so we don't have to proceed further. Okay, so yeah, let's now implement it. So as you can see, this is the left part and this is the right part, right? So what we have to do, we have to split array into the left part, right part, and based on the pivot point. Okay, so this is going to be pivot. So this one doesn't include the pivot point and this one doesn't include the pivot point. And if you remember in one of my recursive video, or I think in like a previous sorting algorithm, I have used the recursion, right? So how I have done recursion there for splitting, it is something similar to that, but a little bit different. Okay, let me show you how we are going to implement it. It's just it's a simple implementation, so you don't have to worry that much. Let me write it here itself. Okay, so I'll create a function. It's quick sort, right? Quick sort, and then here I'll pass the array, the, let's say, start index, and then the end index, let's say. Okay, so is start I'll keep by default as 0. So start index is going to be the first elements index basically, and the end is going to be the end elements index. This is what the idea is. Okay, so end is going to be array dot length -1 by default. Okay, so now what we have to do, we simply have to run first condition. If start is smaller than end, that means start index, let's say we have this array. So here the start index is 0 and the end index is something like 0 1 2 3 4 5 6 and 7, right? End index is 7. So if the start index is what you say, smaller than end index, then only we are going to run our code. Okay, and then at the end we are going to return the array. And why we are returning the array whichever we are using, because this is the in place swapping, right? We are going to sort the array in place. We are not going to create a new variable at all. Okay, so now here we just have to write the logical part. So if you remember in the previous code, where is the previous code? Okay, here is it. In the helper pivot we were returning the swapping index, right? And that is what we are going to use to split the array into the halves, the left half or the right half. Okay, so let's quickly use it. Const pivot idx, let's say. Okay, so helper pivot, here we have to pass the array, simple as that, and then start, right? So this is what we have to do. Now we have the pivot index, right? Now how we can split the array into the half is the question right now, right? So for that, what we can do, we can simply call this function recursively, right? And how we are going to call this function recursively is something which we have to think upon. Okay, so here for the first half, what we want the start index, and then we want the elements before pivot index, right? Because here in this case, if you take an example of this array, so if we have passed this array, then what it will return, it will simply return, where is the example? It's hard for me to find. Yeah, it will simply return something like this. Okay, let me write it here. So this pivot index is going to return the index of 5 0 1 2 3 as 3, right? So here if you pass this array, okay, if you are going to pass this array, okay, I have to charge my laptop, that's fine. Okay, so if you pass this array, then what this helper pivot will return, it will sort the array in this like this, and then it will return the index of 5 where we have finally placed 5 in the array, right? It is going to return this. Okay, so what we want to split into two arrays, right? One will contain these elements and another will contain these elements. If you're not able to see, let me quickly zoom it. Okay, so For that, what we can simply do, we have to pass the array, and then start index is going to be start as usual, end index is going to be pivot index minus 1. So if the pivot index it is returning 3, then it is going to be 2, right? So that means 0 1 2, we are going to get these three elements, and then again in the recursive call we are going to get these two elements, and so on and so forth, right? And by now I think you are already familiar how recursion works, right? So the same thing which we are going to do to get the right half. Okay, so for the right half, what we have to do, we don't have to include the pivot index, right? We have to get all the elements after the pivot index. So what we will do, we will simply use pivot index plus 1, and then at the end we have to pass array dot length minus 1, or I think we are passing array, right? This thing we can pass. Okay, so we don't have to explicitly pass the array dot length minus 1 because we are by default setting it here. Okay, and this is it, guys. We have implemented our quick sort. So let me quickly format it. Let's keep it here. I'll remove it at the end. Okay, so now let me first check whether this is working or not. I'm not sure. So here we have console logged it already, right? Helper pivot. So let's quickly replace it with this one, quick sort. So 572198446. So we are getting 1 2 4 5 6 7 8 9. That means it is sorted. So let's add some bigger numbers. Let's say 100. Oh, sorry. Let's say 100, and then let's add 45, and then let's add minus 1. Let's add minus 30, and then let's see what happens. Okay, so we are getting minus 30 minus 1 1. Okay, minus 30 minus 1, and then we have 1 as well. Okay, 2 4 5 6 7 8 9 45 100. That means it is sorting perfectly now. So we are done with the quick sort. And if you still didn't understood the implementation, so this one is basically is splitting, is every time picking the left half of the array, right? So, or where I can write here, right? Left half. Example is this one. Let's pick this one. Okay, let's half array, right? Now the second one, this one is taking right half. Okay, so example is going to be this one, right? And then again, if we are calling if you're calling this quick sort with this array, then again it is going to go through same logics, right? And we are going to loop it until we get start index is smaller than end index. If the start index is equals to end index, then our logic will start failing, right? And that is not what we want. If there is, that means if it is equals to start index is equals to end index, that means we have just one element in the array. Okay, in that we cannot get the like smaller elements or larger elements or something. Okay, so we have to restrict it at some point. So that is why if we are getting start element is more than end element, then only we are going to execute this code. Otherwise, if there is just one element in the array, we are simply returning that array. It's simple as that. Okay, so this is the power of recursion. That is why recursion is important for the sorting algorithms, I would say. Okay, so yeah, this is it for this lecture, guys. Let's quickly jump into the next lecture where we will walk through the code example in browser, right, in terms of call stack. Okay, so yeah, I'll attach the code snippet in the description if in case if you want, you can get it from there. Okay, right, so this is it for today. See you in the next one.